Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about adding and subtracting radicals. So to start with, you have a little box at your notes, and so the coefficients, we're going to add or subtract the coefficients of like radicals, or like radicands, I'm sorry. So right here, they must have like terms of radicands. And the radicands, they must be the same and keep them the same. So here's the concept behind this. When we were looking at like terms previously, 9x plus 7x, we know that we take the coefficient of 9 and we add it to the coefficient of 7 to give us 16x. And in the same way, we're going to do that with radicals. So let's suppose for a moment that x was equal to the square root of 5. So then we would plug that in for x, and it would be 9 times square root of 5. And then we'd plug it in over with the 7, and it would be 7 times square root of 5. And you can notice that here, I'm still going to take 9 plus 7 as the coefficients of these radicands, so the radicals with the radicand of 5, and that's going to end up being 16 root 5. So again, when we have the same radicand here of 5, then it's going to be 9 plus 7, which is 16 root 5. So what does it mean to simplify a radical expression completely? Well, there's two factors that we need to look at. Number one, the radicand cannot be divisible by a perfect square. And secondly, there are no like, and this should say radicands, left in the expression. So looking at example 1, we have 2 root 3 plus 3 root 3. We notice that the radicands of 3 are the same. So when the radicands of 3 are the same, we can just take the coefficients of 2 and 3 and add them together to give us 5 root 3. Next, in number 2, it's understood that there's a 1 coefficient in front of this radical 2. And since they both have a radical or radicand of 2, then we can take the coefficients of 1 and negative 5 and put that together to say negative 4 root 2. Number 3, we have 3 radicals, and they all have a radicand of 6. And so what ends up happening is we take the coefficients of 6 plus 10 plus negative 4. We add those together to give us positive 12, and then the radicand of 6 stays the same. So 12 root 6 is our simplified expression. In number 4, same kind of thing. We have 3 radicals, 2 of which have the same radicand of 7. So when we look at the same radicands here, we can take those 2 coefficients, 9 minus 2, and say that's 7 root 7. And then the 3 root 2 here is just going to tag along, and this expression is going to be our simplified expression. Number 5, we have to start with simplifying each individual radical that has a perfect square still in it. So 8 has the perfect square of 4 in it, and 32 has the perfect square of 16. So we're just going to break those down one by one. So we would break this first one down into square root 4 times square root 2, and then the 2 on the outside stays the same. Now, the next one we know is 16 times 2. So that's going to be square root of 16 times square root of 2, and then the 5 stays on the outside. Now I can turn this square root 4 into just 2, which is what was shown here. So now on the outside I have 2 times square root 2. But here I can turn this square root 16 into 4. And so now on the outside I have 5 times 4 times square root 2. So let's go back to this. 2 times 2 on the front here is going to be 4 root 2. And then 5 times 4 on the outside is going to be 20 root 2. So this expression, or this radical, simplifies to this. This radical simplifies to this. Now the middle one is already simplified, so we're just going to drop that down in the middle. And you can see I kept the signs of subtraction the same. And now I have 3 common radicands. So radicand of 20. So this is going to be 4 minus 3 minus 20, which is going to give me negative 19 root 2 as the simplified radical. And then lastly, number 6, Again, we're going to start with just simplifying each individual radical. So here, we're going to start with the 75. That has a perfect square of 25 times, and then times 3. The next one also has 25, but it's going to be 25 times 2. Now, the 25s, the square roots of 25s, those are going to turn into 5, and then also turn into 5. Notice how the 8's just dropping down and the 2's just dropping down. The square root 3 is dropping down and the square root 2 is dropping down. So now I just take 2 times 5, which is going to be 10 root 3. And then here it's going to be 5 times 8, which is 40 root 2. And then this plus sign just drops down in the middle. And since these two here don't have a common or like radicand, there's a 3 and a 2, then we would say that this expression is our simplified expression. So we would circle this as our final simplified expression. And that concludes our video lesson.